Alright, let's start looking at Trig Unit Test Review Worksheet 1. The first problem deals with continuity conditions. So let me walk through those three conditions first of all. First is that the point has to be defined. F of c has to be defined. The point has to exist. And the second condition is that limit must exist. And if we're looking at a piecewise function, sometimes there's two branches. So we will look at the left branch limits of the function as x approaches c from the left side of c will approach a y value, and then the limit as x approaches c from the right side of c also is going to approach a y value, and we're testing to see if these two agree. Okay, if these two agree, then that means the limit exists and the second condition will pass. Okay. And then the third condition is where the limit exists, the point exists, but now do they exist at the same point? Okay, and that's the third condition. Okay, in this case, as it is, the point does not exist where the limit exists, so therefore this will be the third condition would fail, and this would be removable discontinuity. But if this point exists where this open circle is, then the point exists, the limit exists, and the limit exists where the point exists. So all three conditions pass, and therefore the function will be continuous. Okay, let's look at number one. Find a constant a such that the function is continuous at a given point. So we're trying to get down to the value for a so that these two branches will meet at the same y value when x approaches 0. Okay, so if we look at this branch is going to exist to the right of 0, and this branch will exist to the left of 0. So let's first find out information about this branch, since we have too many variables. If we find the one side limit as x approaches 0 from the right side of 0, since this is where the graph exists, of our function 7 sine 2x over 4x, okay, we can use the Trig theorem, where sine of 2x over 4x is simply going to be 2/4 times 7, which is 7/2. That's after we cancel out the 2 and the 4. So we know that the one side limit from the right side of 0 is 7/2. So in order for these two branches to meet, then the limit as x approaches 0 from the left side of 0 must also be equal to 7/2. So we can simply set a minus 2x equal to the limit on the other side. Now, limit as x approaches 0 from the left side of 0, we can simply plug in 0 for x, so that will just be a. So a is equal to 7/2. And if we let a equal to 7/2, then we have a function that is continuous. And just to step through it some more, if I replace a with 7/2, then these two, I can go through the continuity conditions for this piecewise function, and all three will pass. So first, g of 0 is equal to 7/2 because 0 will be applicable for the second piecewise function, 7/2 minus 0, which is 7/2. The limit as x approaches 0 will be 7/2. Okay, we tested the one side limits, and they're both 7/2. And finally, the limit equals 7/2. The point is also at 7/2. So therefore, third condition passes. The limit exists where the point exists. Okay. For B, we just go through the same thing that we did for part A. We find the one side limit for the first piecewise function. We find the one side limit for the second piecewise function, and then from the result of that, we can set them equal to each other because we want them to agree at the same y value when x is 0. So limit as x approaches 0 from the right side of 0 is going to be 1 minus 2x over 2x minus a. So this is, we're going to use Trig theorem. 1 minus cosine of x over x is simply just going to be 0. So 0 minus a is negative a. Limit as x approaches 0 from the left side of 0. First thing we do with limits, anytime we see a limit, even if it's one side limit, first thing we do is we plug in the target x value and see what our solution is. So plug in 0 in for x, cosine of 0 is 1 plus a. We can set that equal to negative a, which is the one side limit from the first branch. Set them equal to each other. 1 plus a equals negative a. negative 2a is equal to 1, so therefore a is equal to negative 1/2. Okay, the third, part C, one-sided limit as x approaches pi from the right side of pi for tangent of x over 4 is simply just going to be tangent of pi over 4, which is 1. Limit as x approaches pi from the left side of pi of negative 2 secant of x plus a is simply just going to be negative 2 secant pi plus a. Secant of pi is just going to be negative 1. Two negatives cancel out, becomes positive 2 plus a. And then we can set 2 plus a equal to 1 and solve for a. A is equal to negative 1. Okay. Rolle's theorem. So determine if Rolle's theorem applies for secant of x on the interval from negative pi over 4 to pi over 4. If so, find all values of c in the interval such that f prime c is equal to 0. So three conditions for Rolle's theorem we have to pay attention to. First, is the function continuous on the closed interval between our endpoints? And is the function differentiable on the open interval between the endpoints? And finally, do the endpoints equal each other? Okay, so all three conditions have to pass in order for Rolle's theorem to apply. And if all three conditions pass, then we can guarantee that there's a point between the endpoints where f prime of c is equal to 0. Okay. For secant, if you think about secant, secant does have vertical asymptotes, but those vertical asymptotes will occur where cosine is equal to 0. And cosine is equal to 0 at pi over 2 and negative pi over 2. And those are outside of our intervals from negative pi over 4 to pi over 4. So we know that our function is continuous on the closed interval, and because it's a trig function, they're always going to be differentiable as long as it's continuous as well. So we can go ahead and state that it's differentiable on the open interval. So next step, we test the endpoints. Plug negative pi over 4 into our original function. Secant of negative pi over 4 is simply root 2. And then plug the other endpoint, pi over 4, into the original function, into secant of pi over 4, and that's also root 2. So our endpoints do equal each other. So all three conditions pass, we can move on with Rolle's theorem. So we set f prime equal to 0. So first find derivative of our function. Secant's derivative is simply secant x tangent x, set that equal to 0. I'm just going to go ahead and change everything to be sine and cosine. So sine of x over cosine squared of x is equal to 0. Notice we're looking to see where the slope is equal to 0. We're not looking for critical points, so we're only going to be considering the numerator. Okay? The denominator equal to 0 will not tell us where the slope is 0, tell us where the slope is undefined. So we're only looking at the numerator. Set the numerator equal to 0, and I'm going to list out all the possibilities. So 0, pi, negative pi, 2 pi, negative 2 pi, and we're going to see which one of these fit inside our interval. All of the other options, pi, negative pi, 2 pi, and negative 2 pi, these are outside of our interval. We're guaranteed 1, and 0 does fall between the interval, and c is equal to 0. All right. Next problem here, number 3. This is with the mean value theorem. So mean value theorem has two conditions. First two are the same with Rolle's theorem, and it says that our function has to be continuous on the closed interval and differentiable on the open interval. And these two passes, if these two conditions pass, then we can guarantee that f prime of x is equal to the average slope, or the slope between the endpoints. Somewhere between the endpoints, there's going to be a point where the slope is going to be exactly the same as the average slope. All right. So 2 sine of x plus sine of 2x. If we know anything about sine and cosine, is that they're always continuous and differentiable. So we can go ahead and just state that there's not going to be any vertical asymptotes. Okay. So first two conditions will pass. So then we find the endpoint so that we can find the average, find the slope between the endpoints. Plug 0 into our function. We get 2 sine of 0 plus sine of 2 times 0, which is simply going to be 0. Sine of pi is also going to be 0. So our endpoints have the same y value. So change in y over change in x simply just going to give us 0. So our average slope is 0. We find our derivative. Okay, 2 cosine of x plus cosine of 2x times 2 to go through a chain rule for this portion. We find our derivative, set equal to 0. I'm going to get the cosine of 2x out of the double angle, make it 2 cosine squared x minus 1. Combine like terms, distribute combine like terms, and I can factor this, which gives me 2 cosine x minus 1 times cosine x plus 1. Cosine x equals 1/2 at pi over 3, and 5 pi over 3 cosine x equals negative 1 at pi. But we got to always check with our interval. We're guaranteed 1, but if there's anything more than 1, we have to make sure that those are make sure that they're inside our interval. 5 pi over 3 is outside our interval, so we take that out. Pi is also outside of our interval. Well, it's on the interval, so we can include that. Okay, mean value theorem and Rolle's theorem only guarantees a c-value that is between the endpoints. So x is pi over 3. Pi over 3 does lie between 0 and pi, so c is equal to pi over 3.